Hello all and welcome back. So in this video, let us now move forward and try to implement the insertion sort algorithm. Now in the last video, we discussed in length what exactly insertion sort is, how the same is done, and you would also have a coding exercise where you must have tried to implement the same. Now let us try to understand it again from the philosophy of implementing it. Again, we are given some elements. So 12, 25, 11, 34, 90 and 22. Let us write the index as well this time 0, 1, 2, 3, 4, 5. Now, the very first thing to understand is that we have to divide our array in a way, right? Now, if you would have implemented it, was a lots of shifting and insertion which was there in this algorithm. We will try to see if we can simplify it somehow. Now, similar question you must have done, like I have added that after the algorithm, after the data structures, the inbuilt data structures were taught in your course. But I'm pretty sure that if you have skipped any question, then you will be facing the problem in implementing this algorithm. Okay, so just make sure that you do all those questions. They have very nicely been placed there to make sure that you are able to put in your mind and implement algorithms like this. Now moving forward, everyone, very first thing we have to start from this particular element, right? I'm going to take this as, let's say, current card. So let us talk in terms of card only, because that's how you will always remember insertion sort as well, and you will not get confused. Down the line, within a month or somewhere, you will get confused like which algorithm was what. So that's why I've given you those mnemonics. Bubble, we create a bubble. Selection, we select. That school example, we select the person and ask him to come. Insertion, via card, we insert the card. Okay. So right now my 25 is the card, and I have to find the correct position for this particular card, right? So let us see this, everyone. Let us see for first for 1. This correct position, I believe, should go from 0 till the starting of the array, which is 0 only. So how can we say that? Current card, whichever card I have, minus 1 to 0. So this is what our overall 25 or the card at first position should be checked with, right? So we have to check, like for example, for this card, I have to check it from 2, which is current card minus 1, all the way to 0. Okay, so that's the understanding. For 5, check from 4, which is 5 minus 1, all the way to 0. Okay, everyone. So I hope this is clear. Now let us see how exactly this will happen. We will first compare it with 12, which is at 0. Okay, so this will go from 0 to 0. At 0, we have 12, so no shifting will be there, and we can come out. There is one more thing which we will try to employ here. That is, we will first try to shift all the element and make space for my element, the one which I want to add. What do I mean by that? So let me try to explain that, everyone. See, we will have an element or array like this. Let's say here I am picking up this card. Okay, so let's say I am picking up this particular card and say it is at I index. Okay, I'm going to save the value of this particular element of this particular card. Let's say this is some 5. Now what I will do, I will go down this whole left to find out the right position. Let's say I find the right position somewhere here, which is at jth index. Okay, so my j is actually the correct position here, which will grow from I minus 1 all the way to 0. Okay, everyone. So I know that, okay, after traversing, I have found the right position j. I will be keeping on decreasing j, and somewhere I will find the right position. Now also I cannot make it 5. I cannot make it 5 directly because I have to make sure to shift these elements. So what I will do is, every time I am checking, like let's say for example, when I check for just this particular element, if it is bigger than the current position, than the I will just shift it here and make it like this. So let's say for example, let's say there is an element which is 10, which is at just left to I. So it is at I minus 1 part. Okay. What I'm going to do, I'm going to make the I as 10. So I'm going to shift it. With that, I will not lose the value of 5 because I have saved it somewhere else. I will save it in my current. Okay, so this will become more clear once I will implement it. But that is what the philosophy is, so that our coding is easy. We will keep on shifting these elements till we get to the right place, and then we are going to increase it to the right place. Then we insert it, not increase, insert it to the right place. Now let us see everyone. Let us try to dial in this now again. For 1, we have seen that it is at the right position. For 0, we will first compare it with 1. And we will see now that, hey, 25 here, if we see for 11, which is 2, we will first check with 1. So it will say that, hey, 25 is bigger. Okay, so what I should do? I have this current saved with me. So current card is equal to 11. I will cancel this out and make it 25. Okay. Now I will check it with the next one, which is at 0. Here also, we should be doing the shifting. Cancel it out and make it 12. Now finally I have reached to the end, right? Because I'm on 0, I cannot go anywhere. Minus 1 is not possible. Hence, if you will see now, my j is 0, the correct position is 0. So I will make sure to put 11 here. Okay, great. So in a similar way, I will now do for 3. It will go for 0, 1 and 2. Now 34 is bigger than, and let me write it 2, 1, 0 instead. 2, 1 and 0. 34 is bigger than what is present at 2, which is 25 now. It is not 11 now. So I don't actually need to go anywhere here. Okay, I don't need to even see these cards because I'm aware that, hey, if 25 is smaller than me, then all of them will also be smaller. They are all in a sorted manner, right? So that is the understanding. Next, I'm going to see for 90. Here also, it should go from 3 to 1, 0, but they will never get executed because on 3 only, we see that a smaller card is present. Now, if 34 is less than 90, in our example, if 34 is less than 90, then everything to the left is of course less than 90, right? Final one is going to be 22. Okay, so for 22, let us try to redraw the array, everyone. Let us redraw it once. So till now, my array is something like this: 11, 12, 25, 34, and 90. This part is sorted, and I have 22 now. It's, let's say, the new card which I have to insert. Now pay attention, everyone, what exactly is going to happen. So for 5, I have 4, 3, 2, 1, and 0. This time, I will first compare it with 90, and I will save it in my 22. I will save this current as 22. 90, I will see that, hey, 90 is bigger. It should come to the right. So I should write 90 here. Okay, let me just remove that cross. So 90 will come here. Great. Now we have not lost 22. Still 22 is there with us in the current. Okay. Next is 34. 34 is also bigger than 22. It will come here. 34. Next come 25. 25 is also bigger. So I will make it 25. And you will see in this way I'm doing shifting, right? Now when I will compare with 12, I will see that, hey, 12 doesn't seems to be bigger than 22, which is my current, which means that my j will be somewhere here. So my correct positions will be somewhere here, which I was running this correct position. Okay. At this plus 1, I should insert 20. I should insert 22. So here I will insert 22 and I will break out of the loop. Okay, everyone. So I hope this is clear. Now again, it's going to be a lot more clear once we code it. But that's the easier way to do it, this particular thing, instead of doing shifting and everything. By shifting multiple elements, we have just combined the idea of shifting and insertion. We are first shifting everything and then we insert once at the right position. That is what I'm doing. Okay, everyone. And this is what we do in our mind as well. We don't, when we are playing cards, so if you see this example, we don't make this 4 first here, then 4 first here. No. we shift these cards and insert it once. And that's the basic idea as well. We don't do it like this. Let's say we will keep first we will keep 4 here. Okay. Second, yeah. So it is not able to write on that. No worries. It will not be happening, everyone, that I am writing and 4 is I am keeping here. Okay. Then I will keep on shifting it. It is not the way we do it, right? If I get another 1, then I will not be like, I will be putting 1 at each and every position. No. We will shift all these cards and find the right position to insert 1. Okay. Great. So let us try to code this, everyone. Now in coding, let us just copy this part, insert it here. A function insertion sort with an array. Okay. Now, exactly what we said, let us see. N is equals to length of my array. That's the very first thing which we should write. We were starting from 1. We were starting from 1. Okay. Let me keep it current card so that you remember this. It will be easier to understand. What I will suggest, you can use I and J in your implementation. Okay. For current card in range 1 to n. Now I think you're comfortable with this thing that I can go from 1 to n. Okay. Great. So the current, let us take it current and let me say current card. Okay. So current card is going to be whatever card I have in I. So this way I have 25 with me now. When I say that I'm starting from current 1, I have 25 with me now. 1 minute, yeah. Now pay attention everyone, what's going to happen now. Once I have this, I will say try to find the correct position. Okay. Initially I will take it equal to I minus 1. So it will go from I minus 1 to 0. Okay. Great. Now pay attention. Okay, it should not be I minus 1. My bad. Let us make it current only so that you understand this. Normally, I have seen that it is easier if you use these friendly names while learning to code. But with time, you will also shift to I and J. So for people who are experienced, they will not be overall having any confusion. But for someone who is starting from the very scratch, just like the way I did, this will be a lot helpful. Because using these names, it's helpful to revise very quickly. So tomorrow, let's say after a week, when you will pick up this particular code, you will remember that yes, it was taught in a way with using current and current card, all these things. Now, while your current position, correct position, okay, while it is greater than or equal to 0, okay, we cannot go beyond 0, that is for sure. I will have to see the cards till the 0th card. Now see what will happen. If, okay, if array of correct position is less than current card. So what I'm saying this time, everyone, pay attention. When I got 34, this was my current card. Currently, I was on 3. Correct position could go from 2 to 0. But I found out that, hey, this current position, 25 is less than 34. Then I think we should not do anything. We should just break out, because if this is smaller, then everything on the left is going to be smaller. Right, everyone? What does that mean? If this is the case, we should break. Else, what we should do? Array of correct position plus 1 equals array of correct position. Right, everyone? And now I should also do one more thing. I should just move to the left. Okay. Now we could have entered this condition in while loop only, but I want to keep the code simple. So pay attention what exactly is happening here. Let us draw this here only. Let me explain you with respect to this particular example. So pay attention, everyone. Let's say 1 minute. Great. So let us say we have something like this: 11, 12, 25, and 34. Okay. So see, we can forget the rest of the array. That should be fine. If I'm getting this particular case, so I know the current card is 34. Current is 3. If I write it 0, 1, 2, 3. Correct position will start from 2 and go all the way to 0. So it will start from 2, 1 and 0. When I just check it with 2. Okay, correct position is 2. When I check it with current card, I am able to see 25 is less than this particular thing. This means I don't have to do anything. Okay, that is all fine. But now let's have an example where we have to do anything. So if we have 11, 12, 34, 25, 1 minute, 25, 34, and say this time we have 22. Okay, so pay attention everyone. Now let us see how we will dry run this particular part. Yeah. This is 4, 3, 2, 1, 0. What I'm saying? I am saying that this is my current card. Okay, currently I'm holding 22. Great. I am assuming this is the correct position. I want to find out the correct position, right? So if this is not the correct position, I have to do something. I see that the element at correct position, it is not less than my element or the current card which I have. That means what I have to do here, everyone. So pay attention. There's a just slight change which we have to do. It should be correct position. Yeah, it is fine. I am saying that correct position is 3. Correct position plus 1, which will be 4 this time, equals correct position 3. So all I'm saying is move this card to 34. Now, have I lose the value of 22 this time? I don't feel I have lose that value. Why? Because I am having that value saved. Let me write this in white, everyone. Let's say it is 34. This current card, I have the value saved here, which is 22. Now pay attention. Once this is done, I am subtracting this by -1. Now what will happen? Correct position will become 2. So correct position, I'm saying it is 2. Okay. Again, 25 is greater. It is not smaller, it is greater. So this time I want it to be present at 3. So this is 2. This is 2 plus 1. It's going to be 3. So cancel this out and write it as 25. Now when I come to 1, when the correct position becomes 1. Okay everyone, when the correct position become 1. This time I found out that, hey, this 12 seems to be smaller. So I don't need to go to the left. I will get every element will be smaller than this only. Which means that I have to insert my card now because I found the position. Where should I insert it? I should insert it at position 2. I should be inserting this at position 2 because at correct position, I am finding that this is smaller. Okay. So what I have to do, everyone, pay attention. Once this is done, array of correct position plus 1 equals my current card. And we are all done with this thing. Okay. So let us try to return and run this, everyone. Return our array. And let us try to run this. Insertion sort. Okay, pretty sure that each and everything will be clear now based on all our discussion, the visualization, everything. I am able to get my array in a sorted manner. Okay, so we have just applied what all we discussed. Again, you can use INJ for the very first time. People who are writing the code for the first time, I have just made sure that I'm using this correct position and correct card terminology so that it is helpful for you to revise. One more thing, you will have to do this dry running yourself. It will be a lot clear, like 100% more clear once you try to dry run this yourself on what exactly will happen. You have to make this table the way I'm making it, take an example and try to see how the values are changing. Once you're able to do that, you will be able to understand each and everything for sure. Okay, everyone. So I'm pretty sure that now this will be a lot clear. This is the whole code. If I have to just change it or write it easy, I can just use I and J. But I believe that each and every one of you will be able to understand this easily because we have discussed the same thing here as well. Okay. Cool, everyone. So just try to write it down if you face the problem, right? This is the easiest overall implementation. I am just doing the insertion once and I'm just shuffling or not shuffling. I'm just shifting my cards one by one. And after that, the correct position, I'm doing the insertion. Okay. Cool, everyone. So now let's meet in the next video. Please make sure that you do this in the coding exercise as well.